Why is it necessary to use finite element analysis program for segmental bridges? We're going to go over why is it required, the typical modeling issues, how MyDaCivil can help, and the automated design as per AASHTO LRFD. As you might know, these type of bridges need to be carefully analyzed because of the different elements that come into work, whether it's cables, concrete, time-dependent material properties, creep shrinkage. All the things together can be very hard to analyze, and that's why you will need, or ideally use, a software that can reduce the time and be more accurate, because it can take into consideration all the factors that go into this type of analysis. Typical modeling issues for segmental bridges: you have the change in depth. As the bridges or the segments are constructed, they get reduced in size of the section. So having a program that can handle that is very important. You know, the amount of tendons. I'm going to show you later on different functions that you can use to model those tendons. You can do them automatically. And also the stages. As you know, in MyDaCivil from the previous trainings, you can simulate the construction stages in the program, and this is very important for this type of bridges because you can consider camber construction. You can see how much moment is generated and the effect of the tendons that you assign to the bridges. There are multiple types of construction for segmental bridges. As you know, you have the balanced cantilever bridge, you have incremental launching as well, span by span construction, and in all of them you must check the loads, the stage construction stage erection loads for each one of them, where you have the balanced cantilever with a car that's going to carry a segment, the wet concrete, the hardened concrete. So all those things come into play when you are performing the analysis of these type of bridges. So that's why it is very important to perform them using a finite element analysis program. As for you guys now, be MyDaCivil. Also, if you want to consider the temporary supports, you can also do them in the program. And how does the program can help you setting up the models? So we have, in the program, we have different types of construction methodologies that you can use. We have different, what we call wizards, and I'm going to show them to you right here in our platform. So I'm going to just open up a new file and see how we're going to do this, or the different types of wizards that we have available. So if you go into the structure tab, Angela probably showed you the pre-stressing and the composite girder wizards, but you also have in our program the different type of segmental constructions that you can use to generate the model. We have FCM, incremental launching, movable scaffolding system, and the full staging method. These are the four main types of construction available. And if you start from, let's say, free cantilever method, you can define the sections. It's very similar to the methodology used in the composite bridges. You can define the duration of each construction stage. All of them You can define all these under the model tab. The peer table, the length of the segments, and the key segments as well. And you can take this image into for references. K1, K2, those are the key segments, and the FSM part, which will be the full staging method, the part of the bridge that will be supported or temporarily supported during construction. You can define the dimensions of or the length of each one of the segments. The good thing about this is that the program with those lengths, the program can generate the segments automatically and can also perform the construction stages for each one of the parts of the bridge. So you wouldn't have to worry much about generating groups or creating different loads or generating the tendons one by one. So it is very useful. And as you know, after you use the wizard, you can modify the bridge without any problems. The other tab that we have is the section tab. In the section, you can define the starting and ending section for the bridge. And from there, the program will generate that variation of the curve in the model. You also have an option here for defining the traveler load, the form traveler. Usually it is defined with an eccentricity, and as you know, you should consider or include the wet concrete load. That way you can have an idea of the moment generated due to the wet concrete, and then you can get the moment generated due to the hardened concrete with the cables and the stresses and stressing and everything. And then you have the tendons tab. In the tendon tab, you have the positioning of the tendons, also the jacking stress that you can apply. You can define the jacking stress here, and you can tell the program the position of the anchorage for each one of the cables. So let me just open up a model and let's see from there how we can do this type of analysis in the program. All right, so when you use the segmental FCM bridge, you can define the different properties of the bridge, and the program will do something like this, in which, as you might know, you have to have the section properties defined, the material properties defined, and then from there you can generate the different types of elements on the bridge. And the program, the best thing about this is that the program is going to generate the different construction staging, as you can see here, but it will also generate the loadings for the wet concrete, which you need to KIPS. It will generate the loading for each one of the construction stages, including the pre-stressing, the wet concrete, and it will also generate the moment that it creates due to the eccentricities. Another thing is the cables. The cables will be also generated automatically using the wizard, and from there we can check each one of the cables or the forces for each one of the construction stages. So in this case, what I'm going to do is I am going to first run this model to show you the different results that you can obtain in the program. This is one way of doing the bridge. Another way of doing it is by generating a section for each one of the segments, And then from there, Angela went over the definition of properties and sections. For those that are working on segmental bridge, we have a PSC uh, type of section that you can automatically use for generating the boxes. You can use this PSC with the different types of sections available, or you can bring them from CAD. It's up to you, depending on the section that you're using. You can bring them also from CAD. And what you will do is you will have to create, after you generate the geometry of your bridge, you will have to create the groups for structure, boundary conditions, and loads. The procedure is very similar to the composite bridges. And from there, you can manually model this type of segmental bridges. Let's check on this bridge and see the different results that we can obtain in the program. After running the construction stages, you can also perform seismic analysis. You can perform whether linear, nonlinear analysis. It's up to you. After running this construction sequence, we're going to go and check out the different forces that we can obtain due to the loading that we find in the wizard. Another thing is that if you want to change this loading, you can just right-click on the different loads and click on the table. You can also do a sorting as per, let's say, load case by right-clicking. And then from there, you can manually change these values using copy and paste from Excel, or you can manually change the values here and it will automatically update the models. Just in case, if the form traveler changed, the weight change, those things happen and you want to reevaluate the bridge, your model, you can change that and then the program will automatically change it in the model. So if you want to check a particular stage, you can just select it, and after running the analysis, let's check the different types of forces that are generated. So let's say that you want to check the dead load or the forces only due to the dead load. It's going to generate a moment here. Let me just take out the cables. Let me take out the cables from here. And as you see, as you increase the construction stages, you will increase the moment at the pier because this is only the dead load. If you're going to get a summation, which will include the pre-stressing, tendons, creep, shrinkage, compressive strength, you can also use this option for summation. First, last stage, and you can see how the bridge closes from one stage to the other. That would be another option. Just in case Angela didn't go over the time-dependent material properties, you can define time-dependent material properties in the program. As you can see here, you can define creep, shrinkage, and compressive strength of the members of the bridge, the different elements. We have a database for the definition of the creep, shrinkage, and compressive strength. You have ACI, AASHTO, CVFIP, so depending on the location of the bridge that you're designing, you can use the different types of codes. Also for the compressive strength, you can define the properties of the compressive strength and the program, or the different codes, and the program will automatically generate the compressive strength graph. You can also use the user function if you have information for the concrete. You can copy and paste that info from Excel as well. After you define the compressive strength and creep and shrinkage, there's an option called material link that you can use to connect that creep and shrinkage function that you define to a particular material that you have assigned in the model. Something like this I have already defined on my model. You can select it and add it. That will be the way of doing it. Another thing that you can do or that is very useful in the program, after you analyze the bridge, in the program we have different functions for the definition of the, let's say, camber, for example. Camber control in segmental bridges is critical. At the end, you want the bridge to close using a key segment. So having the different deformations as per construction stage is very critical for this type of bridges. So for that, we have an option for generating a camber, or it can be graphically generated, or it can be a table as well. So in order for you to define the camber, we have different functions for that. In order for you to define the camber, we have an option called camber control. And for the camber control, you need to have different groups assigned to it for the definition of the camber. So let's say that you want to define the camber for this particular bridge. And in this case, what you will have to do is you will have to define the camber control. And in this camber control, you have these three different types of groups. You have the bridge element group, the support node group, and the key segment group. For that, you will have to define a bridge element group that is going to contain all the elements of the superstructure. You can name it bridge element group. Let me just open up this model. You can name it bridge element group, and from there you can select all the elements on this particular bridge. Then you have one for the key segment, which will be this one. You can add one that is called key segment, and simply drag and drop. And another one that is called support group. The support group will be located under the supports, in this case the piers and the end supports. Let me just open up one model that has both of them. After you define that support and you have the support groups defined, you can tell the program to give you the camber generated. Just save this one. As you can see here, I have defined a group that has the key segment, which will be the segments here, the bridge girder element, which is the superstructure, and the support nodes, which are the elements that are under the supports that are at the end of the bridge, and also the piers. Let me just run this one. If you use the wizard, the program will generate those groups automatically. And then from there, we can obtain the camber in the program. Let me see. So just going over a little bit of the wizard, you have the definition of the materials. You have also the definition of the number of stages that you want the bridge constructions to have. You also have an option for defining the zones on the peer table, the size, which basically is the length of the peer table. Then you go into the section tab. You can define the section properties. Then you have the tendon option, in which you can define the tendon properties or the tendon layout in each one of the segments. Another way of generating the tendons is using the tendon definition manually. This tendon definition can be applied using coordinates, or you can bring the layout of the tendons from CAD. That's another option in the program. If you want to define the tendons using coordinates, you can just go into the load, tendon and pre-stress, and here you have an option for defining the tendon profile. In this case, I have all of them defined, but just for your information, you can bring in, copy and paste the layout or the coordinates of the tendons in the longitudinal and horizontal direction, with its variation of the vertical direction as well. So just in case you don't want the wizard to generate the tendons for you, you can assign them automatically or manually defining the different layouts. Another thing is the definition of the tendon property. My adhesive can handle internal pretension and post-tension cables, and you can also handle external cables. So you have the three options here, depending on the type of bridge that you're doing. Probably Angela went over for the pre-stressing, so I'm not going to spend much time on this part either. So after you do the analysis of these type of bridges, you can go into the camber control and you can define the different groups. After you define the groups, there's a FCN camber, and the program can give you the graphical view of the camber, and you can bring in the summation, which will add up the cables and the dead loads and everything, and you can obtain the camber graphically like this one. You can zoom in, you can zoom out everything, or you can also obtain a camber table that can be used for the construction of the bridge. So you have different pages, and each one of the nodes tells you how much it is deforming per construction stage, or will give you the construction camber for each one of the stages. So that way the contractor can know how much he should deform each segment, and then to obtain a proper closure of the bridge. There is another option in the program that is tendon loss for segmental bridges. So you can here see how much each one of the cables is deforming in each one of the construction stages. So for example, if I want to check tendon top 1 per stage, the program can tell me how much tendon losses I am having graphically, or you can also obtain the tendon losses under the tables. You can obtain the tendon loss for each one of the group depending on the different stages or the stage that they were activated. You can obtain the elastic deformation, the immediate losses, grip shrinkage loss, relaxation loss, and the stresses on the cables. Another thing that you can obtain for this type of bridge that is also very important is the tendon elongation. You can tell the contractor how much elongation you should be getting for each one of the cables. So this is also very important. Let me change this to inches and kips. For construction purposes, to have that information as they do the tensioning of each one of the cables. You can tell them how much elongation they should expect for each one of the cables. All these properties come into play for the proper construction of these type of bridges. So it is good that you guys are now, can use MyDaCivil to take into account tensioning, time-dependent material properties, construction stages, construction loads, also obtain elongations, deformation, losses on tendons, and as you know, you can run seismic analysis. You can also do the moving load analysis and every type of analysis that you need for bridge analysis and design. So if you guys have any questions regarding segmental bridge, now will be a good time where you have modeling questions or any questions regarding the tendons or construction methodology. It will be the time to ask right now. All right. Okay, so I'm gonna jump into a bit more complex type of bridges, which are the the cable state, and also the suspension bridges. So for the cable state bridge, the process in MyDaCivil is you model the cables with the bridge itself, the girders. You apply self-weight and unit load for the pre-stress force for each one of the cables. Then you use something called unknown load factor, which is a function especially for cable state bridge that we have available in the program. Then you have to use the tuning cable force using the cable force tuning. And then you can determine the initial pre-stressed force in the cable. This is the process. You basically find the initial cable pretension force. Then you perform the construction stage analysis. You verify the forces and adjust the pretensions. After that, you can generate a camber for the tower and the girders. After that, you can perform again the construction stage with the camber and verify the tensions in the cable. From there, you can verify the final displacement on the bridge and then determine the pretension for each one of the construction stages. For cable state bridge, we have Wizard as well that you can use. It's very simple to use. You can graphically use this image to guide as a guide for definition of the length of the elements, the height of the each one of the pylons, the towers, whether you're doing a symmetric or asymmetric bridge, you can also define it here. Uh, the properties, material, sections, and then the cable distances and the heights of each one of them. As you might know, for this type of bridges, usually there's no typical section to use. So what is usually done is you can bring a section from AutoCAD and then use it for your particular project. If you want to bring in a section from AutoCAD, you can use something called Section Property Calculator, which is under the Tools tab. What it does is it will calculate the properties of the sections, like areas, inertias, and you can bring that information into the model that you're using. So, unknown load factor. For those of you who are not familiarized with the unknown load factor, this function basically optimizes the tensions of cables at the initial equilibrium position of a cable structure. The program can calculate the initial cable force by inputting restrictions such as displacements, moments. You can tell the program that you want a particular force, and it will try to satisfy those constraints. So, how do you use the unknown load factor in the program? This is what would be a cable stay bridge without the unknown load factor. You have the bending moment on the girders before the cable force tuning, and here will be something with the cable force tuning. You know, there's like a big difference. So let me go over the unknown load factor and bring in a model that we can use for that. For the unknown load factor, you first need to have a cable stay bridge defined. You can have a cable stay bridge, very simple one or a very complicated one. It's up to you. Let's open up the different types of bridges here. So for the unknown load factor, can have something like a bridge like this one. Let me see the audience here. In which you can define the girder as a frame element. The cables are defined as truss elements, like this one, just for the actual stiffness. And for this one, what we did was we define a unit load for each one of the cables. So if you check on the load and go into the pre-stressed or pre-tension load, you can tell the program how much loading are you applying to each one of the cables. In this case, we applied a 1 unit load for each one of the cables, just so that the program can perform the unknown load factor option. Let's just run it and see how we can use the unknown load factor function. If you go into the cable control, you have the unknown load factor option. Here you can tell the program the different constraints that you're gonna have. For example, if I want to restrain the force of a beam, which is the element 1001, I want to restrain the moment from an upper bound of 5,000 to a lower bound of 5,000. You can tell the program, create a constraint like this one, a constraint like that one, and you can tell the program which constraints you want to use for the definition of the unknown load factor. You here at the bottom have the option of telling the program the loads that you know and the ones that you do not know. So for example, if you use the self-weight, you already know the self-weight of the structure, so that is a force that you know. But then the tendon or the pretensioning of each one of the cables you don't know. So you can tell the program what you know, what you do not know, and then from there you can use the get unknown load factor function so that the program can tell you what the force for each one of the cables should be. You can make a load combination out of it. And then from there, the program, you can check, for example, here, the load factor that was applied using a load combination. After that, if you check the forces, let's say the beam diagram with the unknown load factor, let me add the legend, you can have something like this for the, change it to keep foot, for the unknown load factor, just with one unit load. But then if you check the bridge using the load factor combination that we just generated, the moment on the girder reduces from 51,000 to about 4,000 kip foot. So this shows you the importance of the unknown load factor and how to get the pretensioning on the forces. The pretensioning force on each one of the cables for your cable state bridge. Unknown load factor is one of the functions that we have. We also have one that is called cable force tuning. For cable force tuning, let me just save this one. For the cable force tuning, you have an option of changing the forces on each one of the cable and see how those forces act on the girders or the pylons. It's up to you. So if you go into cable control and use the cable force tuning, let's say, let's use for the unknown load factor, you can see in the program the deck moment or the pylon displacement due to the different loadings on the bridge. For example, if I want to have forces like the forces that I obtain here in the bridge, you can see what the pylon displacement will be due to those load factors that I have applied. You can also change those load factors. And as you change them, you can see what the displacement on the pylon will be. You can check the displacement on the pylon, or you can see the moment on the deck. That is another option. So let's say I increase the force or the tension in this particular element. You can clearly see how it will change the moment on the deck. So using this function can tell you how other elements on the bridge are being changed due to the tensioning that you applied to each one of the cables. These are the two main functions that we have for the cable stayed bridge. If you guys have any questions regarding the cable stayed bridge, you can go ahead now and let us know. Cable force tuning, basically what it does is it reduces the repetitive computation process to obtain the optimum cable pretension. It also calculates the effects of the cables on displacements, member forces, stresses through the influence matrix, and it updates the results in real time. The process will be you adjust the cables, and then you select the results for which you want to check the effects. Then you produce those effects graphically. You can set up a boundary as well, minimum and maximum, and then you can save those forces. For the cables, you can do different types of analysis. There's one that is called forward, backward analysis. One of them you go from the bridge build and you go back, or you start from the pylons and you go and tension each one of the bridge parts. You also have something called lack of fit force. That is basically the difference that you obtain from the difference in displacement that you obtain from the key segment. And from the unknown load factor, you can see automatically update the table, the tension on each one of the cables. Using the camber control, as I mentioned, you can obtain the construction camber or the manufacturer camber as well in the program. That is also very important for this type of complex bridges. So if you guys have any questions regarding this, now will be the time to go over any questions that you guys have. All right. So the last part that we're going to go over is the construction suspension bridge. And for the suspension bridge, we have different functions in the program that we can use to perform the analysis of those bridges. In MyDaCivil, we have 4 suspension bridges. We also have a wizard. That is this one. The wizard basically has the different, is very similar to the cable stayed one. The main thing here is generating the geometry of those cables, like the hangers, the cables. That is a very complicated part of modeling this type of bridges. So that's why we have created a suspension bridge wizard to help you with the generation of that particular geometry. As you can see, it's just one window in which you can define using this image as reference. You can define the different types of elements, dimensions on this particular type of bridges. After that, you can use the program to do something called the suspension bridge analysis control, in which the program takes into consideration the small displacements and large displacements for the generation of the nonlinear analysis of the cables. When you define the construction stage or when you use the wizard, the program generates initial forces for large displacements and for small displacements, because it uses that to generate the stiffness of each one of the cables. As you can see here, we're using tension-only elements, which are the cable elements, and in order for you to properly define its stiffness, you need to define an initial force for their strict geometric stiffness, whether it is large displacements or for small displacements. After you have that, you have an option for suspension bridge, that is this one, in which you can define the number of iterations that you're using and the method that you're using, or using the initial force on an optimization approach, and you can tell the program the group of nodes that should be updated. That will be the location of each one of the nodes that the program should update for after performing the suspension bridge analysis control. And you can also define a sag point. The nodes to be updated are all the nodes on the hangers, as you can see, and the sag points or nodes are the ones that are all the way in the midspan of the bridge. If you run this analysis, what the program is doing internally is running iterations to obtain those forces for each one of the cables. If you perform that analysis, the program will do this, in which it will take the initial forces. After you perform that, you can delete the suspension bridge analysis, and then from there you can rerun it so that the program can run the analysis of the bridge using those particular forces. Then, after you use the forces, let's say we define it with the self-weight, we can obtain the actual moment displacements, like deformations, due to a particular load case or load combination, as you can see here. You can define those load cases, and then you can get the deformations for each one of the load cases in the bridge. This is a little overview of these functions. If you have any questions regarding that, now will be the time. Please feel free to let us know if you guys have any issues. And thank you for your time. Hope you have a good rest of the day. Bye-bye.